Fred Woodall and my partner Dylan Bobbitt and I are going to explain how we do number one. We were asked what point on y equals square root of x is nearest to the point 4, 0. Here's a little graph to show you what's going on. Now we started off with finding a distance formula, which we found to be square root of x naught minus x1 squared plus y naught minus y1 total squared. Then we set our points equal x1 and y1 equals the point 40 from the known equation, and then x naught y naught we set equal to x and square root of x from the equation we know.
If we take these 2 points and plug them into our distance formula, we're going to get this equation, square root of x minus 4 squared plus the square root of x minus 0 squared. And when we simplify that, we get our d of x equals x squared minus 7x plus 16. When we take the derivative of that, we get it to be 2x minus 7 all over 2 times square root of x squared minus 7x plus 16. When we set the derivative of that equal to 0 and we solve for x, we will get that x equals 7 halves. Now that we know that x equals 7 halves, we can find our y value because y is f of x, so f of 7 halves will be the square root of 7 halves. So our x naught y naught value, the point closest to the point 40, is going to be 7 halves at square root of 7 halves.
Now the reason we know that this is a relative minimum is because we know that the original function f of x, if we take the derivative, we get 1 over 2 times the square root of 1 over 2 square root of x, which is positive. So we know it is a minimum and the function is increasing as x increases.